Hello everyone, in this video we will be learning about expressions in C programming. First we will understand what are expressions in C, and next we will explore the different ways of writing expressions in C programming. And finally we will look after the different kinds of expressions in C programming with simple examples. Let's get started. First, what are expressions in C? An expression in C programming combines operands and operators to produce a single value. It is a mix of operators, constants and variables. Operands in expressions can take the form of variables, constants or even other expressions. Operators performs actions like addition, subtraction, multiplication and division on operands. Expressions are used in statements to assign values to variables and control program flow or to perform calculations. Look at this expression, x equals a plus b. In this, x is a variable which represents the memory location where the data can be stored and manipulated. Whereas a and b are the operands, equal and plus are operators. The equal operator is an assignment operator which is used to assign the result of the expression on the right side to the variable on the left side. The plus operator is an addition operator used to add the values of a and b. Now let's understand how expressions in C can be written using different formats or styles. Here are the 6 ways of writing an expression in C language, which are infix notation, postfix notation or reverse polish notation, prefix notation or polish notation, unary expressions, binary expressions, and ternary expressions. In infix notation, the operator is placed between the operands. Now look at the example. In expression a plus b, the addition operator plus is placed between the operands a and b. And this is the classic example of infix notation where the operator is placed between the operands. Now look at the next example. 5 asterisk x minus 3. Here the multiplication operator asterisk is placed between the operand 5 and the expression x minus 3. The expression x minus 3 is also in infix notation, where the subtraction operator minus is placed between the operands x and 3. So both expressions follow the infix notation format in which the operators are placed between the operands. In postfix notation or reverse polish notation, the operator is placed after the operands. It is often used in stack-based algorithms and calculators. Now look at the expression AB plus. AB plus means add the values of A and B. The operator plus comes after the operands A and B. Now look at this expression. Divide 8 by 2, then multiply the result by 3. The division operation is applied to the two numbers that appear before it, which are 8 and 2. Therefore, we divide 8 by 2. After performing the division, next we multiply the result of the division, which is 4, by the number that comes before the multiplication operator, which is 3. So we multiply 4 by 3 and the final result is 12. Now let's see how this postfix expression is evaluated using stack-based approach. Initially the stack is empty. We push the operand 8 onto the stack. Now the stack contains 8. Next we push the operand 2 onto the stack. Now the stack contains 8 and 2. And then we encounter the division operator. Now we pop the top 2 operands from the stack, which are 2 and 8, and perform division. So 8 divided by 2 equals 4 and push the result 4 back onto the stack. Now stack contains 4. Then we push the operand 3 onto the stack. Now the stack contains 4 and 3. Now we encounter multiplication. We pop the top 2 operands from the stack 3 and 4 and perform multiplication. So 4 times 3 equals 12 and push the result 12 back onto the stack. Now stack contains 12. After completing all the operations, the final result 12 is left on the stack. In prefix notation, operators comes before their operands. It is used in some programming languages and stack-based algorithms. Now look at this expression, plus AB, which means add the values of the variables A and B. Now look at one more expression. In this we subtract the product of 8 and 2 from 3. The multiplication operator is applied to the two operands that comes after it, which are 8 and 2. Therefore, we multiply 8 by 2, resulting in 16. After performing the multiplication, next subtract 16 from the operand immediately following the subtraction operator, which is 3. And this will result in 13. Now let's understand the stack-based approach. We start with an empty stack. We push the operand 8 onto the stack. Now the stack contains 8. Next we push the operand 2 onto the stack. Now the stack contains 8 and 2. Next, perform multiplication operation between the top 2 operands on the stack, which are 8 and 2. Pop 2 and 8, multiply them, and push the result 16 back onto the stack. Now the stack contains 16. Next, we push the operand 3 onto the stack. Now the stack contains 16 and 3. Next, perform the subtraction operation between the top two operands on the stack, which are 16 and 3. Pop 3 and 16, subtract them and push the result 13 back onto the stack. Now the stack contains 13. At the end, the final result 13 is left on the stack. So this expression evaluates to 13. In unary expressions, the operators work on single operand. Unary operators includes negation, logical NOT, increment, decrement, etc. Look at this example. The negation operator is applied to the variable x. This is an unary expression using the negation operator. It negates the value of the variable x. In second expression, the logical NOT operator is applied to the variable flag. And this is the unary expression using the logical NOT operator. It negates the value of the variable flag. In binary expressions, operators operate on two operands. Most arithmetic, relational, and logical operations are binary. It somewhat looks like infix expression, but the basic difference is, in binary expression, we have exactly one operator placed between two operands. Whereas in infix operation, we have multiple operators and operands arranged in a specific order. Look at this expression. The first expression uses the bitwise AND operator between the operands a and b. So it performs a bitwise AND operation between the values of the variable a and b. In second expression, it uses a modulo operator between the operands a and b. And this expression calculates the remainder when the variable a is divided by variable b. The modulo operator returns the remainder of the division. In ternary expressions, it have three operands and are typically used for conditional expressions. The ternary operator is used to create conditional expressions in programming languages. The first expression is the syntax for ternary expression. It says if condition is true, then return value if true, else return value if false. Now let's see how the below expression syncs with the syntax of ternary expression. A greater than b is a condition. It evaluates to true if a is greater than b and false otherwise. Question mark is a ternary conditional operator. If the condition a greater than b is true, a is the value returned. The colon separates value if true and value if false expressions. If the condition a greater than b is false, b is the value returned. So this expression compares a and b and returns a if a is greater than b, otherwise it returns b. Now let's see an example program to demonstrate various ways of writing expressions. First, include the standard input-output header file, which allows us to use functions like printf for output. Main function is the starting point of the program where execution begins. And then we have variable declaration. Three integer variables a, b, c are declared and initialized with values. And one variable result is declared to store the result of infix expression. First, infix expression. Here we calculate the result of this expression using infix notation and assigns it to the variable result. Next, postfix expression. Here we calculate the result of this expression using postfix notation and assigns it to the variable postfix_result. And then we have prefix expression. Here we calculate the result of this expression using prefix notation and assigns it to the variable prefix_result. Next up we have unary expression. This expression negates the value of a and assigns it to the variable unary_result. Moving further, we have binary expression. It performs a bitwise AND operation between a and b and assigns the result to the variable binary_result. And finally, the ternary expression. It determines the maximum value of a and b using the ternary conditional operator and assigns the value to the variable max. And at last, we print the results using printf statement. Now let's run this code. Look at the output. On substituting specific values into expressions, allow us to see how they are evaluated and what results they produce. Now let's move on and understand the types of expressions with examples. In C programming, there are several types of expressions used to perform various operations and computations. And these are the different types of expressions, which are arithmetic expressions, relational expressions, logical expressions, conditional expressions or ternary expressions, pointer expressions, bitwise expressions, assignment expressions, and function call expressions. Now let's understand each in detail. First, arithmetic expression. Arithmetic expressions include basic mathematical operations such as addition, subtraction, multiplication, division, and modulus. And they result in an arithmetic value. Look at this expression. The expression begins with a declaration of an integer variable named result. The equal sign indicates the assignment. So it assigns the value of the arithmetic expression on the right side to the variable result. The arithmetic expression 5 plus 3 is evaluated. The expression consists of two operands 5 and 3 and an addition operator plus. The addition operator adds the value of two operands together In this case, 5 plus 3 results in 8. So the result of the evaluation 8 is assigned to the variable result. So after this line of code executes, the variable result will contain the value 8. Now let's see an example. This program demonstrates the arithmetic expressions in C, which includes addition, subtraction, multiplication, division, and modulus operations. First, include the necessary header files, then main function, which is the entry point of the program. Line 3 calculates the sum of 5 and 3 using the addition operator. The result 8 is stored in the variable result underscore sum, and it is printed using printf statement. Line 5 calculates the difference between 7 and 2 using the subtraction operator. The result 5 is stored in the variable result underscore diff, and it is then printed using printf statement. Line 7 calculates the product of two numbers 4 and 6 using the multiplication operator. The result of multiplication operation 24 is stored in the variable result underscore prod. Then it is printed using printf statement. Line 9 calculates the quotient of 10.0 divided by 2 using division operator. The result 5.0 is stored in the variable result underscore quad. It is then printed using printf statement. Line 11 calculates the remainder when 15 is divided by 4 using the modulus operator. The result 3 is stored in the variable result underscore mod. Then it is printed using printf statement. And finally we have return statement, which indicates the successful completion of the program. Now let's run this code. And you can see in the output each line corresponds to one arithmetic operation performed in the code along with its result. Next we have relational expressions. The relational expressions evaluate two Boolean values that are true or false. They compare two values using relational operators like less than, greater than, less than equal to, greater than equal to, and not equal to. Look at this expression. It is a conditional statement using a relational expression. If x greater than y is a conditional statement, it checks if the value of the variable x is greater than the value of the variable y. If the condition x greater than y is true, then the code block enclosed within the curly bracket is executed. Now let's see an example. This example demonstrates the usage of relational operators with conditional statements. First, include the necessary header files and then the main function. The integer variables x and y are assigned the value 10 and 5 respectively. The first if statement checks if x is greater than y. Since 10 is greater than 5, so the condition is true and the message x is greater than y is printed. The second if statement checks if x is less than or equal to 10. Since x is equal to 10, so the condition is true and the message x is less than or equal to 10 is printed. The third if statement checks if x is equal to y. Since 10 is not equal to 5, so the condition is false and the message x is equal to y is not printed. Overall, this program compare the values and make decisions based on those comparisons. Let's run this code. And you can see the output includes only the messages corresponding to the true conditions. Next, we have logical expressions. Logical expressions includes logical operators such as and, or, and not to combine or negate relational expressions. They evaluate to a Boolean value which can be either true or false. The logical expressions generally combine two relational expressions and return a Boolean value. Logical expressions are made using logical operators like and, or, and not. And here is the truth tables for logical operators and, or, and not. The AND operator returns true only if both operands are true. Otherwise, it returns false. The OR operator returns true if at least one of the operand is true. It returns false only if both operands are false. The NOT operator negates the truth value of the operand. If the operand is true, NOT returns false, and vice versa. Logical expressions are commonly used to create conditions in control statements such as if, while, and for loops, which allow you to make decisions based on the outcome of multiple relational expressions. Look at this expression. This conditional statement is using logical AND operator. X greater than 5 is a relational expression that checks if the value of the variable x is greater than 5. Y less than 5 is another relational expression that checks if the value of the variable y is less than 10. The logical AND operator combines these two relational expressions. The entire expression evaluates to true if both expressions x greater than 5 and y less than 10 are true simultaneously. If the condition x greater than 5 and y less than 10 is true, the code block within the curly bracket is executed. Otherwise, it is skipped. To be simple, the if statement checks if x is greater than 5 and y is less than 10. If both conditions are true, it executes the code inside the curly brackets. Now let's see an example. First include the necessary header files, then main function. In the first if statement, the logical AND operator checks if both the conditions x greater than 5 and y less than 10 are true. Since x is greater than 5 and y is less than 10, so both conditions are true. And the message both conditions are true is printed. In the second if statement, the logical OR operator checks if at least one of the condition x greater than 5 or y greater than 10 is true. Since only the condition x greater than 5 is true, so the message at least one condition is true is printed. In third if statement, the logical NOT operator negates the truth value of the condition, which is x equals 5. Since x is not equal to 5, the condition is false, so the message x is not equal to 5 is printed. Let's execute this code. And the output shows the result of each condition and prints the message based on whether the condition is true or false. Next up, conditional expressions. Conditional expressions are also known as ternary expressions. Conditional expressions evaluate to one of two values based on a condition. They use the ternary conditional operator (?), Look at the syntax. Condition is a Boolean expression that evaluates to either true or false. Value if true is the value to be returned if the condition is true. Value if false, which is the value to be returned if the condition is false. Look at this example. A greater than B is a condition being evaluated. It checks if the value of the variable A is greater than the value of the variable B. If the condition A greater than B is true, the value of A is assigned to the variable max. If the condition A greater than B is false, the value of B is assigned to the variable max. And this is achieved using the ternary conditional operator (?), which has the syntax given above. To be simple, if the value of a variable A is greater than the value of a variable B, then assign the value of A to the variable max. Otherwise, assign the value of B to the variable max. Let's see an example. Include necessary header files. Int main, which is the entry point of the program. Integer variables A and B are assigned the value 10 and 5 respectively. The ternary conditional expression evaluates the condition A greater than B. If A is greater than B, it returns the value of A. Otherwise, it returns the value of B. The result of the ternary expression is assigned to the variable max. The maximum value between A and B is then printed using printf statement. Let's run this code. And you can see the output maximum value is 10 because A is greater than B. Next, pointer expressions. Pointer expressions are used to deal with memory addresses in C. Pointer expressions involve operations on pointers, which are variables that store memory addresses. The pointer expressions can be made using ampersand and asterisk. Pointer expressions include operations like referencing and dereferencing. The address of operator is represented by ampersand symbol. It is used to obtain the memory address of a variable. The asterisk symbol, when used as a unary operator preceding a pointer variable, is known as dereferencing operator. It allows you to access the value stored at the memory address pointed to by a pointer. The dereferencing operator has two purposes. One is dereferencing and pointer declaration. Dereferencing allows you to access the value stored at the memory address held by a pointer. Pointer declaration is used to declare a pointer variable. Look at this code snippet. First, we declared an integer variable named num and initialized with a value 10. The line 2 declares a pointer variable named ptr that can hold the memory address of an integer. The ampersand operator is used to obtain the memory address of the variable num. The obtained memory address of num is then assigned to the pointer variable ptr. Line 3 declares an integer variable named value. The asterisk operator is used to dereference the pointer variable ptr, which means we are accessing the value stored at the memory address it points to. Since ptr holds the address of num, dereferencing ptr retrieves the value stored at the memory address of num. Therefore, the value 10 which is stored in the num is assigned to the variable value. So after these lines of codes are executed, the variable value will contain the value 10, which was obtained by dereferencing the pointer ptr. Now let's see an example. Include necessary header files. Int main, which is the entry point of the program. The integer variable num is assigned a value 10. Next, we declared a pointer variable named ptr that can hold the memory address of an integer. The address of num is assigned to ptr using address of operator. The print statement prints the value stored at the memory location pointed to by ptr. The asterisk operator is used to dereference ptr, which accesses the value stored at the memory address it points to. The return statement indicates the successful program execution. And this program demonstrates the usage of pointer expression to access the value stored at a memory location. Now let's run this code. And you can see the output, which indicates that the value stored at the memory location pointed to by PTR is 10. Moving further, we have bitwise expressions. Bitwise expressions are essential for manipulating individual bits within integer operands using bitwise operators. Bitwise expressions includes bitwise operators like bitwise AND, bitwise OR, bitwise XOR, bitwise left shift, bitwise right shift, and bitwise NOT. And these operators allow you to perform low-level bit manipulation operations which are useful in tasks such as setting, clearing, toggling, and checking specific bits within integer variables. Look at this expression. In this expression, we have a bitwise AND operator which performs bitwise AND operation between the corresponding bits of integer operands A and B. Let's consider two integers A and B. When you perform A and B, it compares each bit of A with the corresponding bit of B. If both bits are 1, the corresponding bit in the result will be 1. Otherwise, if any of the bit is 0, the corresponding bit in the result will be 0. Now let's see an example. This program shows the usage of bitwise operators to perform bitwise AND, OR, and XOR operations. Include the necessary header files. Next, main function, which is the entry point of the program. 5 and 3 performs the bitwise AND operation between the binary representation of 5 and 3, which will result in 1. Next, 5 or 3 performs the bitwise OR operation between the binary representation of 5 and 3, which will result in 7. And the last expression performs the bitwise XOR operation between the binary representation of 5 and 3, which will result in 6. And finally, the return statement, which indicates the successful execution of the program. Now let's run this code. And you can see each line of output represents the result of the corresponding bitwise operation. And then we have assignment expressions. Assignment expressions are used to store and manipulate data. They allow us to update variable values, perform calculations, and control program flow. Assignment expressions use assignment operator to assign a value to a variable or memory location. Look at this expression. Int specifies the data type of the variable x. In this case, it is an integer. X is the name of the variable being declared. Equal is the assignment operator which assigns a value on the right side to the variable on the left side. 5 is the value being assigned to the variable x. So this expression initializes the integer variable x with the value 5. Now let's see an example. Include necessary header files. Main function, which is the entry point of the program. First, we declared an integer variable x and initialized with the value 5. Next, we declared an integer variable y without initializing it. Y equals x plus 3. It performs an assignment expression where the value of x, which is 5, is added to 3. And the result 8 is assigned to y. And finally, we print the value of y after the assignment, which is 8. Now let's run this code. And in the output, you can see how the assignment expressions are used to assign value to the variable. And finally, we have function call expressions. So the function call expressions involve calling a function with arguments to perform a specific task. The function call is an expression that invokes a function and passes arguments to it. The function performs some operations based on the given arguments and may return a value. The function call expressions can be used in assignments, conditions, and other expressions. Look at this expression. First, we declared a variable named result of type integer. And then we have function call expression. It calls a function named add and passes two arguments 3 and 5. So this expression calls the function add with arguments 3 and 5 and assigns the return value of the function to the variable result. Now let's see an example. Include necessary header files. Next, we defined a function named add that takes two integer parameters a and b and returns the sum of two parameters. Inside the function, a plus b calculates the sum of a and b, which is then returned. Int main, which is the entry point of the program. Line 7 calls the add function with arguments 3 and 5. The result of this function call, which is 8, is assigned to the variable result. The printf statement prints the result of the function call to the console. %d format specifier is used to print the integer value. And the result is the integer variable containing the sum. And finally, the return statement, which indicates the successful termination of main function. So this program demonstrates how to define and use simple function to perform addition. The function is then called from main function and the result is printed to console. Now let's run this code. And you can see the output, which is the outcome of calling the add function with arguments 3 and 5, which returns the sum 8.